In the Denton Hospital scenario, we don't need to design any control charts. We just need to interpret them. Let's take a visit. You are visiting the engineering office of Denton Hospital as part of a consulting project. Oh, that's nice. You notice some charts on one wall that look familiar to you. Oh, that's right. Here are some control charts. You recognize those. Now, actually, before we go any further, why don't we stare at the charts for a moment? One thing we notice is that there's two sets of charts. There's one set of chart concerning something about temperature, and there's another set of charts concerning something about humidity. Oh, and then what are the charts? They're control charts. I notice that it's X double bar is in the center of the top one, and then R bar is in the center of the bottom one. Ooh, the top ones are mean charts. The bottom ones are range charts. That tells me something else actually right away without reading any further, is that apparently Denton Hospital Engineering Office needs mean charts, right, the top ones, with unknown natural variation in the process. It looks like they're monitoring something about temperature, something about humidity, and they have two sets of charts. Tells me that starting out, they must not have known what the natural variation is in those two things. That's why they have selected these particular types of charts, because that's what these pairs of charts are the most appropriate for. Oh, okay, so we learned a little bit about them. What else do they have to share? One of the employees notices you reading the charts and explains the primary patient care area, Denton Tower, has over 1,000 individual rooms in it. In all these rooms are dependent on one central air conditioning system, which we monitor throughout the day. Every hour we measure temperature in Fahrenheit and humidity in a random group of rooms and mark the averages from this data on the two sets of control charts. Oh, that's what these marks are. They've been busy already today plotting their observations from random groups of rooms. We like the charts to be out here in our front office for everybody in the department can see any patterns forming on them as the employees pass through here throughout the day. Oh, okay, so that's the scene, but what are the questions? Here in the note frame, the questions are on the second page as it prints out. It says, which of the following is apparently true based on your examination of the charts? This is essentially a set of true-false questions. We just need to look at each one of these statements separately. Let's see, first one, if the average air temperature from one of engineering's hourly samples is below 70 degrees, they would consider air conditioning system to be out of control. Okay, now I need to determine if that statement is true or false. First off, I just want to clarify this. It's asking about temperature, okay, that half, the left half. And it's asking if it averaged at 70 degrees, would they consider the whole system out of control? We have to look at the chart. They were asking about temperature. The reason I underlined it, that means we're over here. They're asking about an average of 70, which means it concerns in particular the top one, the mean chart. I have to ask myself, if you plotted 70 degrees or cooler, where would it fall? What would that look like? Notice that the lower control limit here is 70.76 degrees, which means if it was 70 degrees or anything less than that, it might be right outside it, but it would actually be outside the limit, right? It would be below the lower limit. That's your signal for out of control, right? If one of your observations falls outside of the limit, you go, oh, assignable variation, something must be wrong. We need to react to that and find out what the problem is. So, yes, I agree with this. This is true, right? Because if you marked that bit of data, it would be outside the limits of that chart. Okay, second statement though. At least one of the charts you are looking at suggests that assignable variation is present. Okay, now, we just mentioned that if in marking data, any of the data falls outside the limits, that's a sign of assignable variation. Now remember, I just marked that for demonstration. This is what you can see on the wall. We're looking at where they plotted their observations, and we're not seeing here anywhere any of this data is outside the limits. So say, well, then there must be no assignable variation. Okay, whoa, wait a minute. One sign of assignable variation is if you plot the data right and it's outside the limits, obviously, assignable variation out of control. But another sign of assignable variation, another thing to watch for, and they even kind of hinted at that in describing the story at the bottom of the scenario, is any suspicious patterns within the limits. Because if in marking the data, the only reason that you're getting these shapes is just because temperature naturally varies a little bit and humidity naturally varies a little bit, you shouldn't see any distinct patterns. It should be random. That is a very distinct pattern right there. That's what a lot of people call a run, where what is that? That is the humidity, the average humidity in the randomly selected groups of rooms. They've been plotting it, like 9 a.m., 10 a.m., 11 a.m., noon, 1, and it's climbing steadily. They're lining up. That's a sign of assignable variation as well. Stop, stop. Generally, we don't like to see more than 3 of those line up like that, because that is suggesting that this is definitely not random, and it's kind of elegant. Even though none of these are outside the limits, we already know there's probably a problem, and we need to start looking at this before they get any more humid, and then we have big problems. So, since we have a very obvious, almost exaggerated run, this is also true. That's exactly what it's suggesting, that assignable variation is present. Better investigate. Now, third statement here. The upper left-hand chart is a mean chart in which natural variation in room temperature is a known value. So we have to test this whole thing whether it's true. The upper left-hand chart is a mean chart. Yes, it's a mean chart in which natural variation in room temperature, it does concern temperature. Natural variation in room temperature is a known value. Oh no, this is false. Remember I was saying at the beginning, if you see that mean chart and then it has a companion range chart, that is signaling to you that whoever created all that starting out isn't really very sure about what the natural variation is in whatever's being monitored. That's why they bothered to also do a range chart. So this is false. If it were true, we wouldn't see a range chart. Okay, so in summary, what's that? 1 and 2? 1 and 2 are true. They are supported by what we're seeing there on the wall in the engineering office. Now, let's look at this. Oh, which of the following is apparently true based on your examination of the chart? So this is just another set of 3 true false statements in essence. So take them one at a time. Average humidity in a Denton Tower patient room is 58% when the air conditioning system is in control. Okay, how do I confirm or dispute that? Well, it has to do with humidity. It has to do with averages. When the system is in control, here's the belief. This is the humidity mean chart where you plot average humidity. Its center would be the average overall when everything's fine, everything's in control. And notice that the label there does say 58%. It's centered on 58%. Ah, true. We can see that in the mean chart for humidity. You are looking at 10 hours of past data on temperature and humidity in randomly chosen patient rooms. Okay, so we are staring at this up on the wall. And it says confirm this or dispute it. This represents 10 hours worth of monitoring activity. Well, how are you supposed to tell that The secret is what the employee told you. Every hour we measure temperature and humidity, and we mark the averages on these charts. So are we looking at here 10 hours worth of that? 1 hour, 2 hour, 3 hours, 4, 5, 6, 7. I count 7 marks on this chart. I'll count the other one to confirm. 1, 2, 3, 4, 5, 6, 7. 7 marks on the chart mean that 7 hours have gone by. This has been done 7 times. So this is false. This is only 7 hours of data. Okay, 3. In the data marked on the charts, humidity within a sample doesn't vary as much as temperature within a sample. Okay, the key there is that within a sample. Okay, so you say, how am I supposed to know how much temperature or humidity was varying within a sample? Ah, that's range. Right, the bottom 2 charts are range charts. What is range? You take a sample, like you measure temperature in 10 randomly chosen rooms. The range in that sample is the largest observation, the hottest room, minus the smallest observation, right, the coldest room. Or by how much, when you bothered to go to 10 different rooms, by how much, what's the span that this was varying. So that's what they're marking hour by hour, the span in the observations, within the sample. And one thing I notice is that on the humidity side, see how they're nicely grouped around the center? Whereas, it's not too terribly wild on the temperature side, but it doesn't look so nice and neat there, right? So actually, I'm comfortable with that statement. It does appear like humidity doesn't vary as much within the sample as like what we were witnessing at least earlier in the day with temperature. So I am behind calling that true just by reading and just interpreting the range charts. So that means for this part B, it's 1 and 3 that are true. Now to finish up the problem, it has a part C. Just one little sentence, looks really innocent. The employee who spoke to you said that every hour they measure temperature and humidity in a random group of rooms. But how many rooms are apparently in that group? In other words, what sample size are they using? Remember that sample size is traditionally abbreviated as a little lowercase n in formulas. Well, how are we supposed to figure that out? They didn't describe how many rooms they were bothering to measure every time they sampled. But actually, we can pretty easily figure that out by reverse engineering any one of the control limits that we can see in front of us, right? They have built these charts. They gathered data. They used the appropriate formulas in each case here in order to come up with these numbers. All we need to do is pick one. You can just pick one of these limits and reverse engineer that number. I'm picking, just to pick one, I just happen to pick the upper control limit on the temperature chart. I am going to take it apart. How did they get that number? And in doing that, that'll actually reveal to me apparently how many rooms are in their sample. Because let's think about this. Now, I said you could use any of them. I'm using temp mean chart. Actually, temp range chart. Temp R chart. Upper control limit. Temp R chart, upper control limit. You could use any of them. You just have to use the appropriate formula. Okay, I like this one because the formulas are really simple. The formula for the upper control limit on a R chart is D4 times R bar. Okay, that's how you determine that number. And that number is for them 7.12. I'm just reading it right off of here. Okay, so, and I can even tell what their average range was when they were gathering data to create the charts, because it's right there. R bar means average range. So D4 times 4 equals 7.12. They had some D4 factor and they multiplied it times 4 and they got 7.12. It's simple algebra then to figure out what the D4 they were using must have been, because all I have to do is take 4 and divide it into 7.12. I'm going to jump down here into the footer of the page. D4 equals, that comes out to 1.78 on my calculator. Oh, so they're apparently using for the upper control limit a D4 factor of 1.78. You might be thinking, well, what's this got to do with the number of rooms that were in their sample? Well, where did they get the D4 factor from? How about page 461, I think, of the, yes, textbook. They got the D4 from this chart right here. Maybe not in this particular book, but this was the chart. Because you can see for a mean and range chart, there's a variety of factors that you need for there's the formulas as they appear in the book, and you can get them off of this particular table, is what it is. Now, D4 is the last column here. They were using 1.78, which meant that when they went to that table to go find what they needed, right, they landed on that row. Oh, but what is it, like if you were actually drawing a range chart, you get that table, what is it that you actually look up that you know what row to read? You look in the first column, you look up the sample size. So they looked up their sample size and said, oh, we need a D4 factor of 1.78. That means their sample size must have been 10. If they thought that that was the correct row, then D4 corresponds to a sample size of 10 when they go forth and measure temperature and humidity in their group of randomly selected rooms. Apparently that's a group of 10 rooms.